Okay. So we are ready.
So I would like to share my screen.
Yes.
Just to
maybe before we present your biography and introduce your...
Yeah, and then maybe we can
maybe you can check how it's done. Yeah. But we have technical support with listeners. So.
Yes, he is doing all the job. I've just finished another session, so it was quite okay.
Very efficient, yeah. Mm-hmm.
They helped a lot, although we didn't have any experience with such type of conferences, but it went quite good.
Yes, for me it's new too. I have no chance before. Okay, it's quite working good. Yeah. It's easy because we are at home, but not nice. But we cannot meet personally. Okay. Okay.
Good afternoon.
No.
Okay, it's 4 o'clock, Christoph, I think.
Yes, 4 o'clock. Okay.
We should start because we have later the closing ceremony.
Okay, I will start.
Yeah.
So, good afternoon, ladies and gentlemen. My name is Krzysztof Zawirski. I'm professor of Poznań University of Technology in Poland, as well in State University of Applied Sciences in Piła as the second place. And I have pleasure to co-chair this session together with Professor Koc Arsow from Civil and Methodius University of Skopje, Macedonia. So today presenter will be well known probably in our surroundings, in our environment, Professor Peter Korondi from Budapest, and I ask Professor Koc Arsow to present his biography.
Okay, thank you, Christoph. Professor Peter Korondi is currently a full professor with the Department of Mechatronics, Optics and Engineering Informatics of Budapest University of Technology and Economics, and head of ETO Robotics Group. From April 1993 to April 1995, he worked in the laboratory of Professor Harashima and Professor Hashimoto with the Institute of Industrial Science, the University of Tokyo in Japan, where he continues to spend a month each year working on a joint research. As a result of this cooperation, the Intelligent Integrated Systems Japanese and Hungarian Joint Laboratory was found. In 2001, his research interests include telemanipulation and motion control. He authored or co-authored 15 book chapters, university notes, 121 Hungarian and foreign journal papers, 179 conference papers, including 7 keynote lectures, 12 research and development studies. He held 41 presentations in foreign universities and institutes, and more than 2,000 independent citations to his work. He is a founding member of the International PEMC Council.
Okay.
So Peter, the floor is yours.
Yes.
Okay.
You have some 30 minutes for your presentation.
Not 45. Okay, I try to do.
It's written here 30, but we can give you 5 more if needed.
Okay, yeah.
As we are early.
Yeah. So it is my pleasure to be here and present my lecture on machine learning algorithm in the field of motion control and mechatronics. You can see there are a lot of contributors of this presentation. I hope, so can you see, Okay, so I quoted Zdenek. So he asked in the first keynote that autonomous design optimization is strongly depend on availability of reasonable models. What are the constraints and limits he asked Professor Kolar. So I use this sentence, and I would like to answer to this question. So, what I would like to show you and present you that the model identification by experiments, test, because sometimes we deal with not only engineering stuff, and machine learning can be the first step to the autonomous design optimization. So, okay, here is the outline of my presentation. First, I would like to present you the bacterial memetic algorithm for parameter identification I use for motion control system and welding, then a spiking neural network, which we can use image processing. And if we will have time, I will show you something, the fuzzy state model for motion, emotion, and behavior description. That is my research topic. I mean, ethorobotics. Okay, so let's start with this bacterial memetic algorithm for parameter identification in the field of motion control. Here you can see two PhD students who are dealing with this topic, the supervisors and advisors, and I quote here one paper where you can find the details. Okay, so something about the theory of this evolution models. Unfortunately, I cannot put here. So I cannot see my screen. So I don't know whether you know Lamarck, who is an old biologist, who stated that we can inherent of course, the genes, but not only the genes, we can inherit from our parents their experience during their life before they give us birth. He stated, of course, later, where is later, Charles Darwin stated that, oh no, we just inherit the genes and not the accumulated experience of our parents. And later, Baldwin modified a little bit, that we inherit the genes, but in another way, maybe we inherit the experience of our parents. Of course, we know, I could ask who knows the two other persons. I am sure all of you knows Darwin. So it means that theory was so that we think that is the true theory. And the evolutionary algorithm, based on the Darwin's opinion that we can inherit the genes from the parents. And here you can see a short history of such algorithms. What I would like to draw your attention also, maybe all of you know these genetic algorithms, which is widely used. And the question in all evolutionary algorithm, which is a little bit, so what we suggest here, the bacterial genetic type algorithm, but a little bit different. Here you can see the common feature. With all evolutionary algorithms, several possible solutions compete for the survival in a population. So we have several candidates, and they compete for the survivor. It is common in all such algorithms. What is specific in case of the bacterial algorithm? And also it is quite common in this genetic algorithms. We have mutation, crossover, and selection. In our case, the mutation is bacterial type. I will show you what does it mean. The crossing over is a gene transfer. We can call it as multiplied infection, and the selection based on the integral of the error square. It means we can use it when we have we have the good solution. Of course, we can calculate the error. If we cannot calculate the error, we cannot apply this method. So it is really like follows the Darwin's idea. So we just inherit the genes. Here you can see the animation, how does it works. So we have a certain population where we have several bacteriums. Here you can see N bacteriums, and here you can see the genes. In our case, when we will apply for it parameter identification, that genes will be the parameters. So here we have several parameters, and then what we do, we make clones of this bacteria. Then we select a certain gene, and we change the gene. So this clone is exactly the same as the original, but here we change, let's say here we change some parameters because we use it for parameter identification. Then we select maybe the best one. How can we select? From the calculation, the error square, integral of the error square, which is the best one, we select, and then we distribute this gene to all bacteria because that was the best. Then we do for the all genes, and finally we have a new bacteria which is changed. Then we can do for the next bacterium. Then we need the gene transfer. So we have a new bacteria. I mean, in this bacteria, the genes are the parameters what we would like to identify. So what we do, first we divide the bacteria in two halves. And of course, we do depending on the sum of the error square. Here are the better solution, here are the worst bacteria. And then we select again two bacteria, and then select also, for example, two genes. And so actually it is better than this one. So that's why we move that gene to here. In our case, the parameter from here move to here, two parameters, and we do it several times, and then we have a better population. Okay, so let's turn back Darwin. I don't want to debate on the biology. So maybe we really inherit only the genes and not the experience of our parents. But in the engineering field, we maybe can do something else. So we have this evolutionary algorithm, for example, genetic algorithm. They have some advantage. Explore the large searching place, but do only a rough searching, the difficult to fine-tuning it. We also have local searching technique. So it is maybe the genetic algorithm, and the local searching technique, usually the gradient method. Of course, the gradient method also have some advantages, and of course some disadvantages, because we know that sometimes you find a local minimum maximum instead of the global. So what we usually do in the engineering field, of course, combine them, and we have a hybrid solution, remaining global. So the genetic algorithm ensure the global research, and of course we can tune it by a local, I mean, for example, gradient method. So and this is the combination, and we can call it as a memetic algorithm, which was introduced in 1989, and so it is the combination of the global genetic algorithm and the local search, and we can say it can be it is really different what Darwin suggested us. Okay, so here how can we do this gradient optimization? We have no time for it, and here you can see the bacterial memetic algorithm. So we have we can generate a initial population. So we randomly select, for example, the parameters which we would like to identify. We have a bacterial mutation, then a local search. After this local search, which a little bit modify that bacteria, then we apply this gene transfer, as I mentioned, and in this way we can search the best solution. Here is the first example where we used. It is an internet-based servomotor system, which we use for education as well, and it is really good for this. So in this system, in internet-based system, we have a certain controller program, but we can modify the core controller program of this system. The time, velocity, and the position is given when we write the controller program, and the controller output is the torque reference signal. Why torque reference signal? Because we have a DC motor, and we have an inner current control loop. Of course, we don't want to allow to the students to switch the voltage, because maybe they destroy the motor. But if they provide only torque, I mean from the electrical engineering point of view, a current reference value, in this case, which we can limit, of course, in this case they cannot destroy the system. So the output is a torque reference value. We can set a constant value, we can set a sinusoidal value, and here you can see the result, and you can see we have a lot of nonlinear effects: offset, Coulomb friction, Strebeck effect, velocity saturation in this case. So we need a model for parameter identification. For the first grade student, we can introduce a very simple model, and they can identify only 3 parameters. It's a very simple model, but it is not good enough. Of course, we can extend this model. We can include the Strebeck hysteresis loop, and we can provide a more detailed model, which include the current control loop, which is a PI controller loop, and this Strebeck hysteresis loop. And then here is the system description. We have the servo motor, we measure it, we have a simulation model, we compare the simulation with the measured value, and we tune the simulation model by this BME algorithm. And here you can see the result. It is not exactly identified, so it's we have something more or something problem, because we need maybe more accurate model. We used it for pneumatic system. Here you can see the measured friction force, this estimated hysteresis friction. Okay, we used it for motion estimation, and we would like to use it for a robot. Unfortunately, we cannot. So this research stopped by the COVID-19, so our students cannot go to the laboratory to make the measurement. And here there is a important step which I would like to show you. So what was the problem? When we try to identify the parameters, we needed a good model. I mean, good equations. If we have good equations, of course, we can identify the parameters of the identification. But maybe we can step further. We can have a freedom in the structure. And okay, we don't know exactly the equations, and we would like to identify the structure and the parameter together. For that we use the fuzzy description. Of course, we can do something else. And here is the example which my PhD student did. You can see the defense date, so it's almost 1 month ago. So what is the idea here? So you can say, I don't know, welding. So I don't understand the welding, and I try to model the welding without knowing exactly what is welding. So you may say it's strange, but we could do it. So let's assume. What we did, of course, we supported by industrial companies. So the industrial companies made us a lot of experiments. So they made welding with different parameters. They changed the control, current, the voltage, and the speed of the torch, speed of the feeding. So they changed that values, made welding, and then they measured the result. So we had a big database. And what we would like to, what we wanted to do, we wanted to model by fuzzy rule sets. And we tuned these fuzzy rule sets by this bacterial memetic algorithm. When we had the well-tuned model, then we could use it for design the welding. So then we use that tuned model and we use the opposite way. So we so here we know the welding input parameters. The output is the result. The weld bead and what we measured. So first we made a model from the input parameters to resulting welding. Then when we design, we do it the opposite way. We know the desired bead geometry, and from the model we can select the optimal parameters, and we can use this exactly the same bacterial memetic, not exactly the same, but similar bacterial memetic algorithm. So what we can do, we design a model, and we use this model for so first we measure a model, and then we use for designing the system. And frankly speaking, even if we don't know too much about the welding, so of course for this stage we need the experts, but after that maybe we could do without their without their help. And so and here also a very, very important message. So here you can see the fuzzy sets, and we have really, and what is important here, we don't know exactly the physical connection. So we cannot say, okay, we need a linear arc voltage, or the bead width depends on linearly or non-linearly from the arc current. So we have here a model which is really out of the usual engineering mind. So usually we would like to have we need a physical model, and it is a quite abstract model. So that is very important. It's an abstract model where, of course, later maybe we can find the physical connection between, for example, the arc current and any parameter of the welding. And maybe, and this is an important message, we have to change our mind, and we may need a more abstract way of thinking about the system. And of course, here you can see that in this case, one bacteria represents the certain model. In this model, we have fuzzy rules. We can consider the chromosome, and they have a lot of other parameters. But anyway, here you can see the experiments, and here you can see it was working, and we could do it. And I would like to present. So how many minutes I have? Okay, because maybe I need here also a very interesting topic. It is the supervised.
10 minutes, Peter.
10 minutes.
Okay. Okay, I try to do it. So it is supervised learning with a small training set for gesture recognition. But what is the main message and the main contribution here? The spiking neural network. So something about the spiking neural network. More or less, we know the artificial neural network. The spiking neural network a little bit different and maybe more promising than the artificial neural network. So what we know about the neurons and or neurons, that the communication made through axons, signal has a one-way direction. So the signal can start from here and ending here, and maybe here another way can return back. But what is important, the signal has only one-way direction. Maybe that is the most important. And this is an important comparison. So here we compare the artificial neural network, which we usually have, and this spiking neural network. So here, information coding method. So we have here real activation values, and the information is coded in the rate of the activation. What is in case of the spiking neural network, like the human being, only the spikes, so temporal spike train code the information. So the time, it is a time activated network. Description. So the artificial neural network can be described algebraic equation. So it is static. The spiking neural network, dynamic. So we can describe by the differential equations. Of course, we know that if we feedback algebraic equation with the feedback, we can create a dynamic system that we do, for example, in digital electronics. And the native operator, it is global supervised gradient and backpropagation method. What is important here, it is local and unsupervised. So when we know the system, of course, we can use supervised training method, but unsupervised, it means we can create new structures. Biologically, plausibility is important. Of course, different type of the hardware also important, but so here we have real values, constant real values. Here we have only spike trains. And what is very, very important, the power consumption. Since we have constant operation, so that's why the power consumption is higher. But look at, here we can see one order difference in the power consumption. So for example, if we would like to put in the robot, we need a smaller battery because the power consumption is smaller. Okay, also some important thing, maybe I would like to emphasize here that, and it is very important, the result of Z transformation of a spiking neural network is a simple artificial neural network. So, and we can do this transformation in the opposite way. So we can do the connection, the spiking neural network and the artificial neural network. Something about the spiking. So this is the biological background. How does it work? So we have a stimulus. If it is not big enough, of course, it disappears. But if it is cross over the threshold, we have, let's say, a positive feedback. So we have the peak spike, and the information can go through. And then we have a under overshoot. Of course, we can immediately understand the reason, because in this case, we depress the next spike. So we have, so of course, this is the relaxation period when we cannot transfer a new spike by this under overshoot. And here you can see the information representation. So it is just an example, 7 neurons response to a time varying stimulus. And look at only here, only 3 of them have response. It means here we don't need power consumption. So here you also can see it is more efficient. And
about 3 minutes left.
3 minutes left.
Just
okay. Okay. And then so let's see where is the spike. So how can we code the information? So we can code the information. Maybe I just emphasize it can be frequency-based metrics, and as a engineer of power electronics, for me it is PWM, and you can use for PWM time-based metric. It is a modulation technique. So we can use it for normal way of thinking. And maybe it is also important who can develop a system who can learn the system, and a very important rule is fire together, wire together. It is developed or described by Donald Hebb. So this is the Hebbian learning. And it means we have a certain sequence. So if the neuron spiking first and then the next, is it okay? It means they have a connection. So that's why we have to increase the weighting. If the next has the first spike and the previous next, of course, they order opposite. It means they have no connection, so that's why we have to decrease the weight. And of course, it is written or drawn by biologists. So here we have this continuous function. And here you can see the learning method. So this is the consequential, and here is the first neuron. So here the second neuron have spike earlier than the previous. It means they have no connection, because it is impossible to spread the information in this way. So that's why we have to decrease.
Give 1 minute, Professor.
Yeah. Okay. So this is a dopamine mechanism. So we change the rate when we have reward. So this is the reward, and here we can change the rate. And then, of course, I show only the video. So what we do here, maybe, yeah, that is interesting. So we use it for recognizing the sign of the music. Also, let's start. How can I? Yeah, maybe for that I have to go in this way. No, so I. I cannot start this video. So anyway, if you would like to see this video, so my student show the notes of the Hungarian song, and we can recognize, and the robot play in the piano. But if you would like to see it, you can go the Budapest Robot Cafe. We have a good connection with them, and in this case I can skip this way. Here also a robot. But here is the so let's go to the conclusion. So unfortunately I expected a longer time, but anyway. So what is my message? We have to think on the machine learning, and the autonomous automatization of mathematical planning and identification may cause a possible mini revolution in the industry. And so what I would like to emphasize again, we might need to think a little bit different way. So we may need a newer level of abstraction. So when we deal with this machine learning, of course, it should have connection with the physical world, but this connection should be in a higher abstract level. And the last story which I would like to tell you, when I was young, I remember an old professor who mentioned that no, we don't need finite element methods. It is for the mathematicians. Since we lost in this way, when we use the finite element, the real physical meaning. And I remember István Nagy, he mentioned that, okay, don't believe that professor. we always have to use the newest methods. And also what I would like to tell you, so I don't want to be such professor who against the new technology. So I would like to encourage the new generation. Please use the machine learning, and please try to have and reach a higher level of abstraction, and maybe you will be better engineers. So thank you, and really sorry that it was too fast.
Thank you, Professor Peter, for your interesting presentation. Sorry that we have no more time, but okay, we are limited by our schedule. So floor is open for question. Please, any question from audience. So, Professor, maybe I ask you something which you have time to present more precisely about this welding process. As I understand, if you have as the first part of the first step, you need some fuzzy rules, so you need some expert, and then your BMA method learn to, like say, the position of input function and output functions. Yes, this is and after, if you reverse this model,
yeah,
it means that you just correct only the behavior, or you can add some extra rules. Or
no. I use the opposite way.
Yes.
Okay, here. So
yes.
in this case, the training signal is from the measurement.
Yes.
I would like to mimic the measurement.
Yeah, but you need fuzzy rules, yes? Which you learn.
And tune the fuzzy rules. In this case, I would like to tune not the fuzzy system, only the parameters, to have the same output as the desired parameter. So here is the trained fuzzy system, and here I change the input of this fuzzy system to have the same output. So this is the desired output, and this is the output of the fuzzy model, which here I train, and I don't want to change it anymore. I would like to change only the inputs to have the same output what desired, and then we can see here the optimized welding parameter what we need for that result.
Understand. So the structure means that the fuzzy rules are still the same.
Yeah.
But you mentioned about the examples that you can just generate a parameter and structure of the model. You have some experience in this? This approach?
So also here, I don't know the equation between that parameters.
I know, yes, it's clear. Yeah.
And then in this way, we really free in the structure, and maybe we can do more. So maybe we can put together the equations as well. But yeah, it is also possible.
Right, thank you. Any questions from audience? No, sorry that you have not possibility to finish your presentation in details. Thank you very much once more. Thank you very much, Professor. And I think that we are ending the session. And Gotze would like to say some words.
Okay.
Thank you for your very interesting presentation. But today the viruses are more interesting than the bacteria. So I love that you probably should change to viruses.
Okay.
Okay.
Okay. We have a little bit more time. We have spent a little bit more time, but we still have time to attend the closing ceremony. We have 10 minutes for a break. I would like to thank again for all participants of this session, to my colleague co-chair Christoph, and to the Peter Korondi, the presenter, for exceptional presentation. Thank you.
Thank you.
And goodbye.
Thank you.
The closing session, fine.
Welcome, Željko.
I'm here.
Okay,
I'm here, prepared.
good. Oh, I see you are in Dubai still
Yes,
swimming.
yes.
Hot water.
I'm living in
nice
Dubrovnik for the last half of the year.
weather. Good. So see you in September there.
Yeah, hopefully.
Time is now, but maybe we can wait 1-2 minutes for the lay people to give
Yes.
them opportunity to participate. So I think we can start this final session of our conference. Good afternoon, everybody, once more. And it's my pleasure to invite co-chairs for this session, Professor Pavel Bauer and Professor William Fedak, who will co-chair this session with me. And I think that the first and maybe the most important part is to summarize our scientific talk, and this summarizing we'll try to do by our, let's say, best presenter and best paper recipients. So this ceremony will be provided by members of our committee, Professor Grzesiak and Professor William Fedak. So I don't see Professor Grzesiak at the moment. Oh, he's here also.
I am present.
Yeah, very, very good, very nice. So the floor is yours at the moment to introduce some people, and apologize if some IT details will be not ready, because we had only 20 minutes to prepare for this ceremony, and some activities are still in progress, but we will try to present it in full way. So, Professor Grzesiak, please start this award ceremony for best paper and best young paper.
Yeah, good afternoon, everybody. I would like to present decision of the award committee about the best paper. And in the beginning, I would like to say that it was a large number of the very best papers, and from one point of view, I can say that this is difficult to select, but technically it was not so problem, because we have got a nice table with the information from the chairmen, and by using this information, we made the final decision. And I hope the diploma are ready to present, and we can show on the screen the first one. Yeah.
1 second.
Yeah. Okay. The diploma is for best paper, and the paper was presented by Salvatore Di Arco, and he is from the just a moment. I don't see the university name on the screen.
May I comment this? Salvatore De Arco is from Sintef Energy Research from Trondheim, Norway. And co-author is John R. Soule. He is from Department of Electric Engineering Cybernetics, Norwegian University of Science and Technology from Trondheim, Norway. So congratulations.
Okay, thank you very much. Congratulations. And the question is again to the chairman. It is possible to show the photo of the person generally?
Oh, I don't know that we have.
Yeah, during the discussion before the session, it was some option that after the presentation of the diploma, the author will be on the screen, but probably it's not
difficult to find
such option possible at the moment. Okay, in such case, please go to the next diploma. The next best paper award is for Tiago Soeiro. He present the paper, and it is from Delft University.
Yes, is a single-phase transformer-less photovoltaic inverter featuring low common mode voltage noise generation, enabled by AC decoupling and DC link mid-point clamping technique. So the title is almost half of the paper, but congratulations to them.
Yeah.
So all authors are from Delft University of Technology.
Okay.
This is Group DC Systems, Energy Conversion and Storage from the Netherlands. Okay.
The next best paper is, I am waiting for the screen, Jacek Rąbkowski, Mariusz Zdanowski, Grzegorz Wrona, and in this case I don't have the problem to recognize the name of the university. It is Warsaw University of Technology, and the paper have been presented by Jacek Rąbkowski. Congratulations.
Yes. Okay, congratulations also.
And please, the next. The next best paper award is for Christian Frania, Zbigniew Kaczmarczyk, and Krzysztof Bodzek. And in this case also I remember it is Silesian University, and this paper was presented by Christian Frania. Congratulations.
Yeah, I complete your information. They are from Department of Power Electronics, Electrical Drives and Robotics, and from Gliwice, Poland.
Okay, please, the next one. No, it was already. Now have to be Marius Stender.
Oh, Christian.
I see some technical problem.
We were in touch in the progress, so we've lost, let's say, the last sentence. So this is why the not.
Okay, maybe I try to check who. Okay, I already. No, sorry, it is not.
There are students. No, there are students.
It is okay. Maybe I just say
Okay.
that the best paper awards, the last one in this part was for Marius Stender from Paderborn University is in Germany. And I hope the diploma will be present soon, and we can see as well.
So for sure we have prepared everything, but maybe something is, let's say, incorrectly displayed or not completed in our base. So
yeah, probably the diploma for Salvador Di Arco was double, and it looks like that. And okay, but in such case, I can say that.
Please wait a second. We will show this. We have this diploma. I'm sorry for this.
Okay, okay. It is for Marius Stender, Oliver Walscheid, Joachim Bocker, and the title of the paper is Gray Box Loss Model for Induction Motor Drives. And like I already mentioned, the people are from the Paderborn University. Okay, congratulations. And it is end of the first list. I would like to say again to any of the authors, congratulations, really, the paper, all of the papers were very good, and the award is in good hands. Thank you very much.
Maybe before we start second part, I will comment, because some participants asked me, all certificates in good quality will be sent to authors via email, and also we will try to send it in hard copies via post, but please be patient because it takes a few weeks. I hope 2-3 weeks can take, but you will receive your certificates both for attendance to the conference and for all hours which was handled here. So this is the announcement for all recipients. Now we can go to young generation.
Yeah.
Okay, William, it is your turn.
Okay, so I can, but I am waiting which one is displayed, and I shall read this. Oh, this is Eddie Matievich. Eddie Matievich. I was looking up for this. Eddie Matievich. Yes. The title is Adaptive Grid Current Feedback Active Damping for Active Front End Converters. It was prepared by Edi Batijevic, Rahul Sharma, Firuz Zare, and Dinesh Kumar. They are from School of Information Technology and Electrical Engineering, the University of Queensland, Brisbane, Australia. But the last one, Dinesh Kumar, is from Global Research and Development Center, Danfoss Drive, from Denmark. So this cooperation between students and teachers and industry. So congratulations. The next one, please. Oh, it's here. Who is Shimon Folmer? Shimon Folmer, I must look because they are not in order. Shimon Folmer, University of Science and Technology of Poland, DC-DC converter with low input current ripples in hybrid capacitor and boost topology. They are from Department of Power Electronics and Energy Control Systems, AGH, University of Science and Technology in Krakow, Poland. Good. The next one, please. Okay, so Michal Adamczyk. Okay. Yes, current sensor pole detection and tolerant control for induction motor drive. There are two authors, Michal Adamczyk and Teresa Orlowska-Kowalska. Department of Electrical Machines, Drives and Measurement, Wrocław University of Science and Technology from Wrocław, Poland. Congratulations. Okay, okay. So Bo and Jang, I suppose. So he was presented Jang, reconfigurable battery supercapacitor hybrid energy systems with active balancing for vehicle applications. So authors are Xiaolang Wang, Bowen Zhang, Yujing Liu, sorry for bad pronunciation. Electrical engineering, Chalmers University of Technology from Gothenburg, from Sweden. Congratulations. And now the last one. It's again from the author from laboratory of University. Presenter for Dingxiao Liu, co-authors Tim M. Al, Thiago Batista Soeiro, and Paul Bauer. So Delft University of Technology, Delft, the Netherlands. So it's good laboratory, I suppose. Just to in the end, I would like to name the award committee members. Professor Lech Grzesiak is chair, and he is from Warsaw University of Technology. I am William Fedak, vice chair from Technical University of Košice. The following one is Professor İlhami Çolak from Gazi University, Ankara, Turkey. Professor Babak Dahit Mobarakeh, he from MS Master University from Canada. And Professor Stanimir Valchev, he is member, Universidade Nova de Lisboa from Portugal. So that's all from our side. Congratulations to all winners. about this. Okay. We can continue in our program.
Congratulations to all recipients of this best papers. Thank you for their contribution to increase quality of our scientific quality of our conference. I'm very happy that we have so much young people and so much good papers for this conference. So congratulations from my side to everybody. And now it's time to summarize maybe a bit this 3 days, these 3 active days for all of you. And I would like to show you maybe a few slides about the overview of conference statistics, what was done during those days, how many people visited us. So this is my point now. So we spent, in fact, 4 days, because first day was almost full, also because of tutorial, which started at 9 morning, small break, finished at 5:30, so it was quite long. And next 3 days was regular conference days. So we recited 207 papers to the conference system. After turbulence caused by COVID, we finally accepted 133. Some we don't, because of authors, took place also. So 133 papers participated in conference those days. In total, we had 348 people involved as co-authors. So list of co-authors, contributors for these papers is quite long. We did only parallel sessions, no poster sessions. It was impossible in case of a virtual event. So these 24 sessions included all papers. A conference also was enriched by 6 keynote addresses and 3 keynote speeches in the student and young professional track. I mentioned tutorials at the beginning. All papers were divided in 10 regular tracks and 6 special sessions organized by different contributors. So thank you for those who submitted as proposals for special sessions. 6 of them was successful. 2 of them was quite large because of 9 or 10 papers. As for yesterday, we registered 189 participants. 122 was from abroad. 50 were from Poland, except our university and our local team. You see them as technicians at the computer, but they are also contribute. They are researchers at our universities to contribute also with papers. Authors were from 32 countries, and we spent in total about 80 hours, including parallel sessions for discussions, quite a long time. So here we can see map with our contribution. So we have whole Europe, almost whole Europe, and we have also around the world. The most of our participants were from Australia, so we mentioned them during best paper award ceremony. So China, Japan, USA, all the world. Oops, sorry. So to mention our most important speakers, also from all Europe, this enriched this conference very much. It was my great pleasure to host here in Gliwice first handling of István Nagy plaque and to celebrate this 50th anniversary. So this is the main names who was awarded with István Nagy award, Professor Pat Boller and Professor Mariusz Malinowski, and our special Outstanding Service and Achievement Awards for former general chairs and contributors to PEMC Conference. So in case of organization part, we broadcasted all plenary sessions to YouTube, so you can see what happened during these plenary events. Also after the conference, please look at the moment we checked that first plenary session was displayed by more than 300 people. So this is additional channel to disseminate our area of knowledge. So thank you very much for your efforts for preparation. Special thanks to all board of chairwomen. This is let's say a random order here, but I tried to put all people who are involved. Some of them more than one time did this duty. So thank you very much for your support. This is very, very important because our conference was full of program, very tight in the schedule. So everything was as was planned. Thank you for this. And special thanks for many others. So mostly for authors who contributed. Without authors, it's impossible to organize. Thank you for reviewers. They hard work to check quality of papers. I found that the most active reviewers checked more than 10 papers. Maybe I mentioned names because they are with us. So Professor Anton Rasolkin did more than 20. Professor Katic, almost 20, and Professor Goja Arsov, I don't remember exactly, but also huge number. So those three colleagues work very much, but there's not complete list. People who reviewed almost 10 was also a long list of reviewers. And participants, the same like author. Without participants, we can do many efforts, but if we multiply by 0 participants, 0 success. So thank you for participants to producing this, our success. Okay, thank you for invited speakers. They did additional quality of this conference. So tutors, keynote speakers, students and young professional speakers, industry representatives, and other. So thank you for your support from scientific committee of the conference, technical program committee, special session committee, tutorial award committee, who did also hard work recent hours. Thank you for PEMC Council members, especially to executive board for frequent meetings and increasing quality of this preparation. And thank you for our sponsors, especially Yusuf probably is not with us because in Australia we have deep night. So, but his presence during this preparation was also very important and helped for me, and also for all other people and institutions who contributed and helped in preparation. Also, of course, I would like to thank my colleagues because by my hand there is only part of work, but team of people, you found it during these days, and the second side of computer helped me very much. So you can see that we have, let's say, the same size photos, but one woman inside is bigger because around her everything was rounded. So this is also our secretary, also long time did hard work to prepare all papers. I also put one more photo bigger. This is Michał, our IT colleague, who spent long months, not hours, but months for preparation. I hope you use his work in useful. So this is from my side, just short summary. Thank you, all of you, and hope you enjoyed this conference and you found here something what you expect. Thank you very much. Okay, so now I would like to pass voice to Pavel Bauer to introduce next steps, this closing ceremony.
Thank you, Mariusz.
Thank you so much for your great effort.
So I would like to first of all acknowledge the team of Gliwice, as you showed that on the screen. But I would like to say that your role was really great, and you are the driving force behind the success of this conference. Actually, the organization was perfect. The IT support was fantastic. The scientific quality was very, very good. So I am very happy with the outcome of this conference. And as a token of appreciation, we discussed today in the PEMC board, and we would like to invite you, Mariusz, to become a member of the PEMC Council, and we will try to propose you in the next PEMC Council meeting. I hope that you will accept. I have to say that you really made a terrific job. Your skills of organization, management skills are fantastic. You solved all the problems on the calm way, very productive, very constructive way. So I think that you did a terrific job. Thank you on behalf of the PEMC Council and the PEMC Council Board and myself for your contribution and terrific job. And the applause is actually for you.
Okay, thank you, all of you. I'm alone and not impossible to do something, but I would like to say that the preparation for today would be waste of time and effort if I would stop now. So I'm disposal to PEMC Council. I would like to support all PEMC initiatives as is possible. So this is, I'm open.
Okay, can you see my screen now? Yes, you can see my screen, I hope. I would like to give you a glimpse of future PEMC Council logo. Let's see if I can share it again. So this is the logo as it is of today, and it shows the bridge with the transistor and anti-parallel diode, with the words Industry Academia Technology Bridge IEEE PMC. We spent some meetings on designing a new logo. This is not the final version. This is the direction of how it is going to be. And if you look at the screen now, you'll see the new proposal for a new logo. We are still in process of fine-tuning, but basically this is going to be the new logo with the bridge, integrated transistor with the anti-parallel diode, with the PEMC and the words Power Electronic and Motion Control Council. The colors will be a little bit different than shown on the screen, but this is the basic idea. So this is what I promised you to introduce. Now, I would like to look at the future, and about a year ago, on the meeting of the PEMC Council, we introduced the new venue for 2022 conference candidate. In May 2020, we, as a council, approved the candidate, and in June also, Industrial Electronics, EDCOM, confirmed our approval, our approved venue. So I would like to introduce the venue of 2022 conference, which is Brașov, Romania. And I'd like to ask now Vice Chair of the Conference Organizational Committee, Dan Lascu, to present us the future venue of the 2022 conference. Dan, please, the floor is yours.
Thank you very much, and also my warm congratulations to the organizers. And it was an example of a top-level conference here in Gliwice. Pavel, may I share the screen with you?
I guess you may share. Now you will allow Dan to share the screen?
I think it's possible now. Thank you. So I hope you can see my screen now. And so the next and the 20th International Conference on Power Electronics and Motion Control is established to take place in Brașov in Romania between September 25-28 next year. About a few words about Brașov, not many because it will follow a short movie about it. So it's located in the central part of Romania, and it was first documented in the 11th century AD. So you will find a very nice town, as you will see later. About the deadlines, because this is of special interest, for the special session call, deadline will be February 15, 22. Then for full paper submission will be March 15. Notification about acceptance, May 15. Camera-ready paper submission till June 15, 22. The deadline for early registration, June 20. And of course, the conference will take place between 25-28 September 22. We plan to have 12 technical tracks and 12 special sessions with 5 keynote addresses, invited papers, and of course, we shall continue the student and young professional track. And there will be also 3 tutorials for free held in September 25, that is on Sunday. The welcome cocktail will take place the same day on Sunday, September 25. The VIP dinner scheduled for Monday, 26. Gala dinner for Tuesday, 27. And there will be 1 technical tour on Thursday, September 29. Additionally, there will be 3 tourist tours for accompanying persons. So from the organizers, and of course the organizer is the PEMC Council, and the PEMC Council chair, Professor Paul Bauer from the Netherlands, and the PEMC Council co-chairs consisting of Professors Peter Korondi, William Fedak, and Krzysztof Zawierski from Poland. And the steering committee has 2 co-chairs, Professor Kamen Jerigan. He is the Dean of the Electrical Engineering Computer Science faculty in Transylvania University of Brasov. Transylvania University of Brasov will be the host of the conference. And the second one, Professor Mihai Cernat, also we know, all of us, we know him from the previous PEMC conferences. Regarding the technical program chair, Professor Kavor Zivik from Norway will take care of it. Financial chair, of course, will be Professor Yusuf Ibrahim. The publication chair, Professor Razvan Andenica from United Kingdom, and Professor William Fedak will be responsible as a special session chair. For the tutorial chair, we hope to have Professor Freddy Wahlberg from Denmark, me for the industry link, and for the publicity, Mrs. Wanagui from Romania. About a few words about Brasov and accommodation and travel to Brasov. Unfortunately, we do not have any local airport, but the closest airports are in Sibiu, about 130 kilometers west from the city, in Târgu Mureș, 168 kilometers north, and Bucharest, the capital, about 150 kilometers south. The transportation from Bucharest to Brasov is assured by minibuses each half hour, but take care to book them a few days before the flight. And the price will be around 17 euros. The duration of the way, the travel will be about 3 hours, but I assure you that you will see a very, very beautiful landscape through. If you intend to travel by car, the fastest route is from Bucharest to Brasov. And regarding the capitals, the closest capitals to Bucharest, you are given here the distances, which are very significant, I have to admit. About Transylvania University, the host of our conference, the university has 18 faculties, more than 20,000 students, and more than 700 teaching staff. And they host about 100 undergraduate programs and 74 master programs in 18 PhD fields. I have to underline that also the Optin conference took place many times in Brasov, and I am sure that many of you attended the Optin conference in the previous years and know what is about in this town and this university, as Professor Cernat also was responsible for this conference from the Romanian side. So regarding the facilities, The conference center has one meeting room consisting of more than 400 seats. And for parallel sessions, there will be 6 small rooms with more than 50 seats each. And for the poster session, the lobby can host about 200 posters. And of course, there will be a coffee break lobby and catering and lunches lobby for 4. For the sports program, yes, Brasov is a touristic region, and there are many possibilities to have city walks, to visit the fortified churches, the castle around. So I assure that will be a full touristic program for the accompanying persons. The technical tour I mentioned before regards the Research and Development Institute of the Transylvania University of Brasov. This institute was developed very recently between 2009 and 2013 and was financed by European structural funds. And you will find here a possibility to join development of high-level research, and you will see the research and innovation services there. Education in research, that is master and PhD programs oriented, and training on advanced topics in this tour. And it's a very modern building there. So I hope that you had a first glance at what will happen in Brasov in 2022. And I warmly invite you to attend this conference in Romania next year. Thank you. And I think we can run a short movie about Brasov. Is it possible to have it? So as I said, Brasov is located in mid-Romania and is the 7th city of the country. In the Middle Ages, the Hungarian kings invited the Saxons from Rhineland, Flanders, and Thuringia to defend the border of the Hungarian kingdom. And thus the city that in that time was called Corona in Latin, or Kronstadt in German, became the capital of the region named Burzenland. That's why the architecture of the city resembles that of the Central Europe, with fortified churches like Krishnov and Brezhmer, and above all, with the beautiful Black Church, dating from the 13th century with its unique Gothic style. The Council Square, formerly the Marktplatz in German, confirms that Brasov was a trade hub. The most important buildings in the city is the former council house, which was built around 1400 and is located in the middle of the square. This is now the building that houses the Brasov County Museum of History. It is surrounded by very beautiful 18th, 19th century houses, most of them being historical monuments. Limpa, that you can see now, is a mountain in the middle of the city with wonderful sightseeing spots over the old town. There are many beautiful pedestrian old streets in town, and here you will find the narrowest street in Romania called the Road Street. Brown Castle is one of the main attractions, not very far from Brasov, with its unjustified connections with Dracula or Vlad the Impaler. And in Prahovo Valley, you will find also the Palace Castle residence of the first Romanian kings, together with a lot of summer and winter resorts. There is also a good opera in Brasov, and the season will be opened during the conference. And do not forget, of course, the Romanian cuisine, which I assure you it's really unique. Therefore, we warmly invite you to attend the 20th edition of the PEMC Conference in Brasov, with the hope that it will be a success, both from scientific, but also social, touristic, and interhuman relations point of view. So see you in Brasov in 2022. Thank you.
Thank you very much. I'd like to add that Romania is the only PEMC country where the conference was not held yet. So this is the first time we are coming to Romania. So word back to Marius.
Maybe we switch to the room view. Make okay, because this is a tradition to handle a bag for money to collect it for the conference organization. And the stick, I don't know if stick is better than carrot, but this is stick to attract participants for them. So I would like to virtually pass it to Professor Dan Lascu, representative of 2022 conference. And in the next possible opportunity to transfer it via, let's see, by hand, I will pass it to the brush. So, Professor Dan Lascu, from this time, this is yours. In my hand, it's only for.
Thank you very much. I promise to enlarge it and make it maybe thicker. Thank you.
But Marius, I can maybe add that the stick is meant for the bad reviewers to hound them and to force them to deliver the reviews on time.
Okay, we also had many discussions here. What else we can use this stick, because this is quite controversial.
For authors to deliver in time, the paper deliver in time.
Yes, yes.
So next is
Short presentation of conference in EDPE in Dubrovnik.
Yeah, probably there is the next PowerPoint. Yes. I don't know if you have.
Okay, I'm here.
Yes. Okay. Yes.
I'm here. I will share my screen. Yeah. Okay. Can you see the poster?
No, at the moment we see only beautiful Dubrovnik behind you.
Oh. Am I not allowed maybe to share the screen? Can you maybe from your side start?
Okay, we will start presentation from our side. Mm-hmm.
Okay, but now, okay.
Okay, it is.
I'm now sharing. I think you can see now.
Yes.
Okay. Dear colleagues and friends, first of all, I would like to thank to PMC for opportunity to really briefly present our next EDPE 2021 conference to be held in Dubrovnik this September, hopefully. I just went out from one large conference that should happen in Dubrovnik, but it was virtual. And now I'm stepping in another one. And we really do hope that it will be real on-site, not virtually. Just few words about EDPE. You know, it's similar. It's like some co-conference or smaller sister to PMC. It's similar age, but smaller number of participants. I remember that PMC Council, and especially Professor Nagy, strongly supported EDP. Professor Nagy was a regular participant of EDP conferences in High Tatras as well as in Dubrovnik. For this time, we really hope that the COVID disease maximum in Europe is reached, it's behind us, and we really hope that we'll manage to realize the live conference in ancient Dubrovnik. As you know, it's always really very nice there. So everybody knows where the Dubrovnik is, what are its facilities. I will just shortly present the place where this conference will be. You know that the dates are end of September. Date is end of September. The weather should be really nice, and I really hope that disease will be behind us. So where can I change the picture? Where is the? I was not working with. So, okay. Conference site is really in the center. You see, here is the old town, and this is conference venue. Conference venue is old university rebuilt building from University of Zagreb, and it's on walking distance from old town. So there's also accommodation possibility for 50 people. It was always very well placed for tourists and for scientific purposes. This is this building. It's in old wood. It's very enjoyable there. There are facilities for maybe 120 people. It's just perfectly suited for conferences from this size. We always have between 80 and 100 people. There is a perfect place. Everybody who was there, many of you were there. There is a perfect place for welcome party, of course, if weather allows. One year it was terrible, and all other times it was really nice, beautiful weather for welcome party. And I don't want to announce because it's not 100% sure, but we have many places to take conference trip. You know that in Croatian EDP conference, we don't have gala dinner. We have always conference trip with dinner, and it's always in some of the beautiful places in Dubrovnik environment. But I don't want to tell you where, just wait to see if disease is behind us, and there we will all enjoy. And now some important information. Extended abstract deadline is very near, but it will be naturally, as always, changed. You can expect mid of May, maybe 20th of May, to send extended abstract. All information is on our website, and there is also link to paper management system created by Microsoft. It works well, is used in all other EDP conferences. So you can upload your paper, you can upload your abstract, you can suggest a special session, you can suggest a keynote, of course. There's always time. We are always open for good papers. And we expect you to be in Dubrovnik and to finally have a real-time conference after all these virtual events. Although these virtual events are good prepared, but it cannot be compared to a real event. So I invite you all to Dubrovnik in September this year.
Thank you.
Thank you, Željko. Thank you. My additional comment is that usually we had PEMC Council meeting at the EDP conference. At this moment, I am not calling for the council meeting there because it's very uncertain, but we usually had a PEMC Council meeting because PEMC Council members were represented very well at this conference.
I hope that many members of PEMC Council will be there and that we can meet there.
Okay, so Marius, please close the conference.
Okay, so today I would like to present you our address from our Dean of the team, not present with us because of other duties, but recorded for us, let's say, final words. So we'll listen maybe now. We have a number of video materials for today. not everything works until the end. So
Dear participants, guests, and organizers, I am glad that our university and faculty could host such a prestigious scientific event. I would like to thank everyone for participating in the conference, for their scientific contribution, lectures, and discussions. I hope that they have contributed to the development of science and technology, in particular in the field of power electronics, electric drive, and related fields. Although this time we could only host you online, I hope that in the future there will be an opportunity for a face-to-face meeting. Feel free to visit Silesia, Gliwice, and the Silesian University of Technology at any time. I wish you more successful conferences, in particular the next conference in Brasov in 2022, and more important anniversaries of the PEMC. Thank you once again for your participation, the organizational team for preparing the session. I consider the conference closed. I wish you all the best. Stay safe.
Okay, so I can confirm that our conference is unfortunately closed, and now we have time to rest a bit after that. So.
Okay, thank you, Mariusz, again for your terrific job. Applause, big applause to you.
Applause to everybody. Yes.
I'd like to invite you all for a glass of beer, but it's unfortunately not possible. I can only invite William if he is available. And
yes, we can meet this evening in the city.
Yes,
let's meet in the together.
Let's meet in the city for on terrace. Terraces are open now. So, but for now, let's imaginary pros.
Call by phone.
Yes, and again, terrific job, Mariusz. I wish that all PEMC conferences are that successful. Thank you all. See you at the next PEMC meeting, and thank you for support of the PEMC conferences. Thank you, PEMC Council, for all the work and all the organizers. And have a nice day, have a nice week, rest of the week. And let's have a rest a little bit after the 3 quite full but well filled up days. Thank you. Bye-bye.
Thank you. Bye.
Bye. Thank you.
Thank you, Papa.
Thank you.